Okay, I'm just gonna continue. Sorry. Yeah. So what did I say? Here is a power 4 equation. So you actually expect to have 4 solutions, and that suspicion should be proven correct. Okay, it will be actually correct if you learn about complex numbers. What we have here, after we take square root, we get plus minus, is only 2 of the solutions. There's actually 2 more, but it requires complex numbers, which is not in your syllabus yet. So you can just ignore it. Can? Okay, good. Carrying on, what we get now is, if I just write it more neatly, it's actually negative 4th root of 6. I'm not going to use a calculator for this. Leave it in exact form, and the positive 4th root of 6. But are we solving for y? Were we actually solving for y? No, the question is always in terms of x. We made our own substitution. So that's when we should sub back in. Do you remember how the exponential graph looks?
No.
Okay, I draw for you. Must remember. Exponential graph, right? It's like compound interest. Your money grows money for you. Oh, you start off with a principal amount, then you keep on having interest, and the interest grows interest for you, and for more and more money. Oh, then eventually the graph will just look something like this. It goes up very, very fast, keeps increasing. But then before that, here the a bit more sophisticated one would be if x is negative. Here, what it really means is when x is, like, for example, -2, e power -2 means what? 1 over e power +2. Right? Negative power, flip the fraction. You can think of this as over 1. Then you flip the fraction. So in that case, what we will have is a positive number divided by a positive number. Do you agree with this one? So the end result will of course be positive, which means that you will never expect the graph to be below the x-axis or on the x-axis itself. It will always be positive. So that's why it should be somewhere near to the top. Oh, it's getting smaller and smaller. If you just experiment with like negative 10, -100, -1000, you realize the number gets very, very small, 0.0000 something, but it's always slightly above the 0. So that means here's how the graph will look. Something like this. Okay, this is the exponential curve, very famous, must remember. Starts off almost horizontal, but haven't touched the x-axis, and then it takes off. It starts flying. Okay, so the main conclusion here is that it's always more than 0. No matter, oh, by the way, this doesn't just apply to e. It can be any other number you like, any other positive integer. In general, it's a power x where a is more than 0. The graph looks exactly the same now. Okay? Always more than 0. Always more than 0. What is more than 0, to be more specific? I mean, a power x is more than 0. Handwriting. Always for all x values. No matter what x value you put inside a power x, as long as you see a power, it will become positive. Strictly positive. Is that clear? Is this okay? Always positive, right? From this experiment, right? We did it with x equal -2. You can try with other values of x. You'll realize it's always positive. So can you tell me what's the problem over here? What do you see here? On the right.
No.
No solution, yes. Right? Here you see e power x, you are expecting positive. But here they equal to negative. So that means there's no solution. Out. So the only solution is this guy. And the answer is, you don't know how to solve it now, but you will learn it eventually. It's this guy. ln of 4th root of 6. Okay, which is actually the same as ln6, then raised to the power of 1/4. But you can bring the power down. You will learn this in the future. So 1/4 multiplied by ln6. Or alternatively, you can rewrite it as ln6/4. Okay. Can. Then let's just okay, yeah, then that's it already, for this question. I know there's a lot of new content that you never learned before, like especially this part here, especially these exponents. But yeah, you're expected to be able to solve them eventually, huh? Can? Okay, move on. This is question 2. Let's move on to question 3. Simplify this fellow. Okay. This one really testing your pattern recognition. Especially the Pascal's triangle. Let me copy down my Pascal's triangle again. Do you notice anything similar? What do you see?
Same as the fourth row.
You mean the 6th row?
Wait, yeah, sorry.
Yes. Hey, wait a minute. Sorry, wrong. 14641. It should be 4th row. You're correct. Oh my goodness. Yes, 14641. The 4th row. Sort of the 4th row. This is the 0th row. This one is 0th. You start from 0th row. 1, 2, 3, 4, 5, 6. But do you notice a problem? Here it's negative, here is negative. But here is positive and positive. Actually positive all the way. So the reason why, let me just do a quick example. Let's say we got x plus 2 power 4. What we will have is 1, 4, 6. Yeah, correct. 6, 4, 1. Correct? Yes, huh?
Yeah.
But now what if I change it to a -2? You get basically the exact same thing, but now all of the 2's must be replaced with a -2. Okay, let me just use a red pen. -2 means that, okay, -2 here, -2 there, -2 here, -2 there. Can you tell me, a negative number raised to the power of even, negative number raised to the power of odd, what will you get?
Negative.
Yes, or maybe just -1. Negative number or -1 raised to the power of even, like 2, 4, 6, 8. What will you get again?
Positive.
+1. How about if it's odd?
Negative.
-1. Okay, so over here, odd and odd. Right? Sorry, -2 raised power 1, -2 raised power 3. So that means that we will actually get our negative before we get our 2. We'll get our negative before we get our 2 power 3. Does that make sense? While the other guys, because it's even power, maybe I'll color code it, even power, that's why the negative will just disappear. Because you raise to a power of an even number, -2 power 2 is actually just -2. -1 times 2, so -1 power 2 times 2 power 2. This guy is actually just -1 power 4 times 2 power 4. So even power, you see? These two guys, they will just become positive. So they stay the same. However, for the ones with odd power, you will eventually get a -1 out. So -1 power 1 times 2 power 1. -1 power 3 times 2 power 3. And this fellow, this -1 power to a odd number will always bring out a negative sign. That's why we will actually, if we simplify this, we will get the plus sign here and there changes to a minus. Let me use pink color. Minus. Okay, then no more negative signs for all of them. after expansion. Can? So that's why we will get this pattern. 1 minus 4, positive 6 minus 4, 1. This is what we call plus minus plus minus plus. We call this the alternating. Does that make sense?
Mm-hmm.
Okay. So over here, you also notice the alternating pattern. Positive, negative, positive, negative, positive. And then you get 1, 4, 6, 4, 1. So you need to make a good guess. What do you think is your, this is actually just A plus B power n. What do you think is your A? What's your B? What's your n? Notice there's something decreasing. Power 4, power 3, power 2, power 1. So that means the thing inside the bracket at 1 minus x cubed. It's not A, I'm not saying A is 1 and B is x cubed. Wrong. I'm saying that the entire thing inside the bracket, the 1 minus x cubed, is A. Or it could be B. Doesn't matter. Let's just say it's A. The order doesn't really matter. So let's just say it's 1 minus x cubed first. Then you still need to add on something to give you an n. I hope you notice that there's an invisible 1. You can always multiply this by 1 power 0, correct? 1 power 1, 1 power 2, 1 power 3, 1 power 4. Maybe it's neater if I write it out. What I mean is, this fella here, you can always have the invisible. Okay. I think I have to write it out manually. So 1 minus x cubed power 4 times 1 power 0 minus 4 times 1 minus x cubed power 3 times 1 power 1 plus 6 times 1 minus x cubed power 2 times 1 power 2 and minus 4 times 1 minus x cubed power 1 times 1 power 3 plus 1 times 1 minus x cubed power 0 times 1 power 4. Can you see the pattern now? Can you see this? I can simplify a bit more. Mic test, am I still connected? Can you hear me?
Yeah.
Okay, good. Yeah, so continuing on, what you realize is actually I could replace all of my ones here with what? I could replace all my ones here with what? If I don't want this minus to become a minus, I want it to be a plus. What will I get? I can actually get a -1 in each of those bases in red color. Can you see? Do you agree that they're the same?
Yeah.
Because odd power, right? Odd power will give you the odd power will give you the extra negative sign. But here I'm working backwards. I'm working backwards. Okay. Then can you see that this is just binomial expansion already? This is just equals to a plus b power n, where a is 1 minus x cubed. Then b is -1. Can you see that?
Yeah.
And what's your power n? 14641. Power what? Forget already. Just remember, every row that you look at, just look at the second number after the 1. 14641, power 4. 151051, power 5. 16, whatever, then power 6. Oh, the pattern very easy to recognize. 1, 2, 3, 4, 5, 6. Yeah. So, anyways, this is really just power 4, and that's our answer almost. Just simplify a bit more. What you realize is 1 minus 1. They cancel off. You're left with negative x cubed power 4, which is -1 power 4 times x cubed power 4, which is just x power 12. Ta-da! That's the answer. X power 12. Can? Working backwards. Is this okay?
Yeah.
Can? Yeah. So this one is pattern recognition. By the way, these questions are from RI. That's why they're so funny. They're so weird. They always come up with weird questions. Raffles. But I don't know why. Good, but good to know, good to learn. Okay, let's just look at the next question, question 4. So find the value of k where k is more than 0 in the expansion of x plus k over x whole thing power 7 if the coefficients of x cubed and x are the same. So you already learned the r plus 1 formula, right? Like this. X plus y power n. Oh my goodness, my handwriting. Or if you don't want x and y, you can put a and b. Right? Yes? Can I just give a bit more explanation on how this formula came about?
Yeah.
Can Okay, good. So let's just start with a simpler example. Let's say x plus 2 power, I don't know, 3. So what we have x cubed plus 3 times x squared times 2 power 1 plus 3 times x power 1 times 2 power 3. That's not exactly right. That's 2 plus 3 times x power 0 times 2 power 3. So what you notice is that the powers, there's a pattern. Minus 1, minus 1, minus 1. Correct or not? For each term.
Yeah.
Then if I call this the first term, the second term, the third term, and the fourth term, how can you see that there is a link, there is a pattern? This is really just what one choose sorry, this 1x cube is actually just 3 choose 0 times x to the power of 3 minus 0 times there's an invisible 2 power 0. Correct? Yes? Then how do you link the number 1 here with the 0, 0, and 0? You have to minus 1, right? Notice that? Mic test, can you hear me?
Oh, yeah.
Yes, can you see the pattern? Minus 1? Not cannot see. Okay, we try another example. Let's say the 3x squared times 2. How did I actually get the 3x squared times 2? This term here. It's actually I did this in my head. 3 choose 1 times x power 3 minus 1 times 2 power 1. I use a different color highlighter. There's a second term here. Maybe I should put first, second, third, fourth. Second term here, can you see how it's linked to this 1, 1, and 1? Just minus 1, right? Just minus 1. Likewise for the blue one, minus 1. So you just keep on repeating a pattern, you always see that there's a minus 1. So in math, students are often confused by negative numbers and fractions. So we try to avoid that by introducing a plus 1. That's why we have this thing called the TR plus 1 formula. So what this means is that we will assign each of these index numbers, first, the second, the third, the fourth, as R plus 1. R plus 1. In general, R plus 1, R could be some index, some number you have to find. So let's say I want to use the TR plus 1 formula to help me to find this third term. What this means is that my R plus 1 will be equals to 3, which means that R will be equals to 3 minus 1, which is 2. Then I will use the formula TR plus 1, in this case will be T2 plus 1, which is 3. Of course, it's T3 because we want the third term. Then you use the formula. N choose R, in this case we found out is 2, times A power, sorry, the A, I'll just write down first. A power N minus R is 2, times b power r is 2. But what's my a, what's my b, what's my n? This is a, that is b, and this last guy is n. Replace the numbers. So what we'll have is n is 3, right? So we put down a 3 on the top. And the base here is x, a is x, and b is 2. So put down a 2. Are they the same? Sorry, I forgot one more. 3 minus 2. Are they the same? Okay. Are you convinced that they are the same? Yes, okay. Then that's how the formula works. But more importantly, why is there an n minus r here and there's a r there? It's really just because of the formula. But we can see it if I gave a slightly more complicated. I think it's more obvious why this should be true. Once you see what do you call it? Once you see a more complicated example. So let's say you got x plus 1 over x squared power 4. Okay, I'm gonna expand this using the formula. It's just 4 choose 0 times x power 4 times, here I'm gonna simplify it as x plus, okay, you know what? Just to make your life more difficult, I'll put a k on top. So k multiplied by x power negative 2. Oh, then what this means is I will actually have k times x power negative 2 to the power of 0. Then I continue. You know what? Just to save some time, I'm just going to copy and paste this a few times. And I think you can see the pattern more clearly also. Copy and paste a few times. How many times do I need? Power 4 means how many terms do I have? 4 plus 1, 5 terms. 1, 2, 3, 4, 5. And now I just need to change the index. 1, 1, 2, 2, 3, 3, 4, 4. Okay. Simplify. Copy and paste. Okay. Oh, you can do your questions on an iPad also. Then you can just copy paste faster. Yeah. So what you notice, let's take a look at the powers. Oh, I need more space. Over here, what we will have 4 plus negative 2 times 0. Correct or not? Just looking at the powers of x. Do you agree? Mic test, I can't hear you. Wait, sorry.
Say again.
Do you agree that the powers of x here is just 4 plus negative 2 times 0?
Yeah.
Can what about the next one? Oh, sorry, I forgot the minus 1. Minus 2. Minus 3. Minus 4. Do you agree that the pattern is just 4 minus away 1 plus negative 2 times 1?
Oh.
Okay, you know what? Maybe it's nicer if I just gave an even more complicated example. Wait, I'm gonna change the initial example here instead of x, right? I'll change it to x square. So everywhere I'll change to x square. Hold on a second. X square. And I realized I made a mistake here. It should be. Okay, I'm gonna restart this. Hold on a second. Here it should be 3, then 2, then 1, then 0. I think it's better now. Let's take a look at the powers. Take a look at their powers. So over here, if we focus on the power of x, it's actually x to the power of 2 times 4. And then you add on negative 2 times 0. Okay, I'll just get rid of the x. Focus on the power. This part, okay? Yes?
Yeah.
Can okay, then the next one, let's take a look at the power of x again. It will become 2 times 3 plus negative 2 times 1. Next one, I think you can see as well, is 2 times 2 plus negative 2 times 2. Next one will be 2 times 1 plus negative 2 times 3. Next one will be 2 times 0 plus negative 2 times 4. What you realize is that the power here, you see 4, 3, 2, 1, and then 0. And then you see the negative 2, you get 0, 1, 2, 3, 4. Do you see that pattern? Can I cannot hear your response. Is your audio okay? Mic test, I can't hear you.
Oh,
I can hear you now. Can you see the pattern? 3, 2, 1, 0, 1, 2, 3, 4. Can see y'all? So sorry?
yeah.
Yes, okay, then let's simplify a bit more. 2 times 4. Let's just write it out a bit more neatly. The powers. I'll put it in a table like this. Okay, our goal here is to spot a pattern. Spot a pattern. I hope you realize that this is actually just the same as 2 times 4 minus r plus negative 2 times r, where r in this case is equal to 0. Same thing over here, we got 2 times 4 minus r plus negative 2 times r, where r is equal to 1. Is this part okay?
Mm.
Right? I think you can see the pattern already. It's just 2 times 4 minus r plus negative 2 times r, but the r here is equals to 2. Next one, 2 times 4 minus r plus negative 2 times r. R is equals to 3. Next one, 2 times 4 minus r plus negative 2 times r. R is equals to 4. Is that clearer? Can see that pattern? In general, the power will become the power of the first term. Okay, the a in this case is x squared. Okay, if you recall the expansion, what we are expanding is x squared plus k over x squared power 4. So a in this case is x squared, b in this case is kx negative 2. To get our power of the r plus 1 term, we just need to take 2. Okay, sorry, let me color code it. This green color 2, raise it to the power of n minus r. The 4 here is actually just n. And that's the r. And then you multiply it by the other power from the b. Let me color code it. Here's the negative 2 power. Here's the negative 2. Raised to the power of r. Sorry, not power. Oh my goodness. It's multiplication. Multiply by n minus r. And you add them together. Okay, that's what this formula, this pattern that I'm trying to lead you up to. See. Okay, then that will be the power of the r plus 1 term. Okay. Can roughly understand?
Mm.
Yeah. Then I think now we go through the actual example. It'll be clearer. Okay. That was that took quite long. Okay. carry on. Let's just write down the TR plus 1 formula first. Then we solve the question. Okay, let's read the question. So here you got the value of k you want to find. Then they tell you something about the coefficients. X cubed and x, they are the same. So what we can do now is to figure out a pattern, figure out what is the TR plus 1 in this question. TR plus 1 in this case is what? N choose R, but the N is what? A is what? B is what? N is what? A is X, B is K over X, N is 7. Okay, then what is your N choose R? 7 choose R. Bracket times A raised to the power of N minus R times B, K over X to the power of R. This part okay? Mic test. Is this okay? I can't hear you. Oh my goodness. Is the audio connected? Can you hear me? Mic test, I can't hear you. Oh. Hello, Brendan, can you hear me?
Oh yeah.
Can. Okay. Good. Can I continue?
Yeah.
Can. All right, Can, let's go. So you got 7 choose R times X power 7 minus R, then K times K over X power R. So what will we get? Here they tell you about the X cube and the X term, right? So what we can do is we just focus on the powers. So over here, we can clean up a little bit. 7 choose R on its own times X power 7 minus R. But over here, K over X power R is actually just K times X power -1 power R. So if you want, you can distribute the power of R to each of the factors. So K power R times X power -1 times R. Oh. Then you can clean up a little bit. The coefficients is 7 choose R and K power R. And you multiply by X power 7 minus R, and you add on a -R. So that's the power. You can simplify this a bit more into 7 minus 2R. Then here you can finally equate 7 minus 2R equals to power 3, because they want X cubed. Then you can solve for R. I think it will be 2R equals to 7 minus 3, which is a 4, and R is equal to 2. Okay? So therefore, now can you tell me what's the coefficient of X cubed?
Just sub R equals to 2.
Sub R equals to 2. So 7 choose 2 times K power 2. But take note, here, do we need to sub in the, for coefficient, do we still need to care about the X here?
No need.
Don't need, so that's our answer already. 7 choose 2 times K squared. Maybe we simplify a bit first. 7 choose 2 is 7 times 6 over 2 times K squared. 6 and 2 can cancel off. You're left with a 3 here. 7 times 3 is 21. So 21K squared. Okay, that's the coefficient of X cubed. Now we do the same thing with the X. So here, draw a line. X means X power 1. So we equate 7 minus 2R to 1. Then we solve for R. So 2R equals to 7 minus 1, which is 6. R equals to 3.
3.
Good. Then we now can find the coefficient of X power 1. So you just have to sub R with 3. Okay, so 7 choose 3 times K power 3. Do we need to care about the X? Don't need.
No.
Because we only want the coefficient. Simplify this. Actually, just use a calculator. 7 choose 3. 7 choose 3. I think I get 35. Is that right? Yes? 7 choose 3? Can Do you trust me?
Yeah, sure.
Can 35K cube. Okay, so now the coefficients of X cube and X, they tell you they are the same. So what can you conclude about these two values? 21K squared and 35K cube, the coefficients are the same, so they are equal. Yes? Okay, so over here, what do I want? When you want to solve this, right, do you think you can do divide by K squared on both sides? Can or cannot?
I think you just move to one side.
Yes, you should move to one side. Because if you do that, there's a possibility that k squared is 0. Then you divide by 0, which is not good. So I'm going to move the 21k squared to the other side and then move it to the left. I factor out k squared. I'll get 35k minus 21 equals 0. Okay, that means my k squared equals 0 or 35k minus 21 equals 0. K squared equals 0 means k equals 0. Correct or not? But they told you that k is more than 0 over here. So
Reject.
that means that you reject. Yes. So this one you can solve for k, 21 over 35. Use calculator to simplify. You get 3 over 5. Can? Okay, good. Next, part 2. Using the value of k in part 1, find the coefficient of x power 7 in the expansion of 1 minus 5x squared multiplied by that binomial. Okay, so let me copy down the question first. 1 minus 5x squared multiplied by x plus k over x power 7 using that value of k from that we found, which is 3 over 5. You want to find the coefficient of x power 7. Okay, so here, how do you get x power 7? There's a constant here, which is x power 0, 1 times x power 0. There's a quadratic here, x power 2. How do you get x power 7?
You multiply the quadratic with the x power 5, and then you multiply the constant with x power 7.
Yeah, so that means that we actually need the power 5 and the power 7 from the part 1. Using my r plus 1 formula, I can now find the coefficient. And actually, all we need to do is to find the coefficient, right? Because x power 2 times x power 5, we know it will get x power 7. We care about the number in front and the number in front multiply. That's all we need. So negative 5 multiplied by the coefficient of x power 5 and positive 1 multiplied by the coefficient of x power 7. Okay, so our objective now is to figure out what is the coefficient of x power 5? What is the coefficient of x power 7? Okay, and that's all we need to do. So let me just write down what we need at the end of the day. Then we can calculate the r at the right hand side. So for power 5, we need 7 minus 2r equals to 5, which means we can solve for r. 7 minus 5, which is a 2, so r equals to 1. So this means coefficient of x power 5 is just, the coefficient of x power 5 is just 7. Okay, this is the formula here. Okay, I'll bring it down here for reference. Box it up. So it's 7 choose 1 times k. Okay, we already know what's k now. It's 3 over 5 power 1. Type in a calculator, I think I get 21 over 5. Next one, power 7. Power 7 means I'll have to equate my 7 minus 2r to 7. Solve for r. Get a 0, r equals to 0. So 7 choose 0 times 3 over 5 power r, which is 0. I think that's just a 1. Correct? Okay, then now you just need to multiply. How do you get the, what do you call it? What did the question ask again? Find the coefficient of x power 7. Okay, so that means we just need to take this number, which is negative 5, multiply by the first question mark, which is 21 over 5. And then we take the coefficient of this constant term, which is just 1, multiply by this second question mark, which is 1. So the answer will be negative 5 times 21 over 5 plus 1 times 1. This is from 1 minus 5x squared is 1. And that is from there, the coefficient of x power 7. And then color coding a bit more. 21 over 5 is the coefficient of x power 5. And this negative 5 is from 1 minus 5x squared. Yeah, color code it with, I don't know, purple. Negative 5x squared. Okay. Then type in your calculator, I think I get negative 21 plus 1, which is negative 20. Can?
Okay.
Okay, good. That is part 2 done. Next one. Question 5. Okay, let's go. Okay, given that you have this guy equals to 1 plus ax plus bx squared plus cx cubed, and a squared is 2b, find the value of n and find the value of c. Okay, so for here, right, 1 plus x power n, if you try to use r plus 1 formula, you can, but I don't like it. I prefer to manually expand it. Just manual, because it's only until x cubed. So all that you really need is to expand this guy until power 3. Sort of. Okay. Think of it more like yeah, you start from the constant and then you slowly increase to x cubed and then you stop. Okay, don't expand beyond x cubed. Just put dot dot dot. Okay, so that's what we're going to do. So we're going to let f of x equals to this LET. Then that means that we will have to focus on the 1 plus x power n first. First term, if I start from lowest power, will be 1 power n, then x power 0. In front is n choose 0 plus n choose 1 times 1 power n minus 1 times x power 1. Then n choose 2 times 1 power n minus 2 times x power 2. And of course the cubic one. N choose 3 times 1 power n minus 3 times x power 3 plus dot dot dot. I don't need to go to x power 4 and beyond because I just need until x cubed. Okay? X power 4, you multiply by anything else, the power will become bigger than x cubed. So don't need, just put plus dot dot dot. Continue simplifying. Can you tell me what's n choose 0?
1.
1. Okay, so 1, then 1 power n, also 1. X power 0, also 1. So it's just a 1. What's n choose 1?
N.
It's just n. Multiply by 1 power anything is just 1 times x. What's n choose 2? Fraction. N times
N minus 1
n
over
2
2.
factorial. 2 factorial in general, but of course 2 factorial is 2 times 1, so it simplifies to just a 2. Then times 1 power anything is just 1, then times x squared. Next one, what's n choose 3? Fraction. N times
N minus 1 times N minus 2.
You see 3 here, so what should be at the bottom?
6.
6, which is 3 factorial. Then times 1 power anything is just 1, then times x cubed plus dot dot dot. Okay, that's good. Then this is the expression up to x cubed. Then we now need to use the information given to us. They give us coefficients. So we need to multiply all this cubic with this fellow here. Then we compare coefficient and make use of a squared equals to 2b. So let's do that. So f of x is equal to, I'm just going to multiply straight away. Constant multiplied by constant. I'll get a 1. Constant multiplied by nx. Okay, actually, I'm just going to get 1 copy of this. So I'm just going to copy and paste this. Oh. Okay, I'm being lazy, but I hope you understand what's going on.
Yeah.
1 multiplied by this bunch. Okay, then here is negative 2x multiplied by the same bunch. I just copy and paste it. Then positive 5x squared multiplied by this same thing. Negative 10x cubed multiplied by the same thing. Then you only need to focus on the constants up to the cubic term now. So let's figure out where are our constants. There's a 1 here, so I get a 1. Then I don't think there's any other constants. Next one, we go for x, something x, or x times something. Let's see, I have a nx here, so the coefficient is n, plus I have a minus 2x here, so I multiply by a constant. That's the only constant, only linear that I'll get. So negative 2 times 1. So negative 2. That's all. Simplify, I get n minus 2. Okay. Then plus, now I want x squared. Coefficients of x squared. I see n times n minus 2, n times n minus 1 over 2, so I copy that down. And then I see minus 2x, I can multiply by nx to give a quadratic, so it's negative 2 times n. Minus 2n. Are we done? No, still have. 5x squared can times 1. So you get a positive 5. Then x cubed, cannot, definitely not. You want x squared, the x cubed power too high already. So you close the bracket. Then now we move on to the next one, plus x cubed, the coefficients. First guy is this one. N times n minus 1 times n minus 2 over 6. Are we done? No, next one. Negative 2x multiplied by, how do I get x cubed? Multiply by which one?
nx.
X cubed, right? We are at x cubed already. So it's this guy, right? Okay, good.
Yeah.
So negative, no space already. Sorry, I'm gonna, a bit messy. I'm gonna put it at the bottom here to save space. Plus negative 2x multiplied by n times n minus 1 over 2x squared. Plus, not done yet. X squared need to multiply by x. So we get plus 5n. 5x squared times nx, 5nx cubed. Okay, next one, minus 10x cubed multiplied by constant. That's the only guy. So negative 10. Finally done. Okay, plus dot dot dot. Okay. Carry on. What did the question tell us? It's equal to 1 plus ax plus bx squared plus cx cubed, and a squared equals 2b. Find the value of n and of c. Okay, I'll just paste it here. Yeah, so what can we conclude? A is equals to n minus 2. B is equals to all this bunch of nonsense. Then C is equals to even worse bunch of nonsense. Copy and paste, right? With an iPad, I can just copy paste. And A squared is equal to 2B. Find the value of N, find the value of C. So that's the objective, N and C, huh? Wow, how? We know A squared equal to 2B. Then can just substitute. We have A, we have B. So that means since A squared equal to 2B, we'll get, maybe I'll just say, okay, you know what? I'm just gonna write down this. Since A squared equals to 2B, replace A and B, dot dot. What will we get at the end? We will get n minus 2 bracket square, that's A square, equals to 2 times of B. Or 2 times of this B, but you must have brackets. Let's just simplify everything. So n squared minus 4n plus 4. Then 2 times in, you get n times n minus 1. Minus away 4n plus 10. Multiply, you get n squared minus n minus 4n plus 10. Simplify a bit more, you get n squared minus 5n plus 10 equals, on the left-hand side, n squared minus 4n plus 4. Let me get rid of the question to save some space. Then now I can simplify. I notice n squared cancel off. Minus 5n bring over, I get 1n. Oh. Then 4 bring over, I get minus 4. 10 minus 4, 6. N is 6. Okay? Is that okay?
Yeah.
Can so n equal to 6 already, but now we want to solve for C. How do you solve for C? You got a formula. You also got n. Then you just need to copy and paste, replace the n. Okay. 6, 5, 4 over 6 plus negative 2. Actually, the 2 can cancel off. Let me just do that. And negative. Okay, I've got negative. I don't need a plus already. So minus 6 times 5 plus 5 times 6 minus 10. Okay, then just type in the calculator. Yeah, 5 times 4 minus 6 times 5 plus 5 times 6 minus 10. Okay, I get a 10. That's the final answer. Is this easy? Is this okay? Can, I think it's not that bad. You just need to know how to expand the 1 plus x power n, right? Over here, up to the x cube. You need to know you need until x cube. Don't go beyond. Or if not, you're doing extra work. And then you just write it out neatly. Then you slowly expand it one by one until you can get your constant, linear, quadratic, and cubic. Okay, then after that, you just compare coefficients. I think you know how to do this. Yeah, that's this question done. Any questions? If not, I move on. Okay, good. I'll move on. Question 6. Let's go. Question 6. Where is it? Let me find first. Okay, here it is. Okay, question 6. Find the value of k by k more than 0 in the expansion of x minus k over x cubed holding power 8 if the constant term is 7. So we're just going to do r plus 1 formula again. Tr plus 1 will be, here it will be n choose r. So it's, okay, can you tell me what's my a, what's my b, and what's my n first? Let's start with the easy one. What's n? The power.
8.
Yes. What's my a?
X.
What's my b?
Minus k over x cubed.
I'll simplify a bit more to negative kx power negative 3. Then now you have n choose r, right? The formula, if you remember, it's 8 choose r multiplied by the a, which is x, raised to the power of n minus r. So 8 minus r. Multiplied by the b, which in this case is bracket negative kx power negative 3 power r. Can? Now you need to simplify this part. Negative kx power negative 3 power r, I'm going to rewrite it as negative 1 times k times x power negative 3 whole thing power r. What we'll have is a negative 1 power r times k power r times x power negative 3r. Okay, good. So we can use that. Negative 1 power r, k power r, we can't simplify, but no choice, we'll leave it. We'll have to leave it. 8 choose r, you also can't simplify, leave it alone first. You can, but don't need to simplify so much. Then x power 8 minus r, I'm just going to bring it down over here. Then notice that both have x, same base x and different powers, and you're multiplying, so you just need to add the powers. Okay, so adding the power, what do I get? Minus 3r plus 8 minus r. This will give me, I simplify a bit more. Minus 3r minus r is just minus 4r. Can? Tr plus 1. Now they tell us constant term means power is equal to what? X power?
X power 0.
0. So you need the power to be 0. So minus 4r plus 8. You can equate to 0. The power over here. Then you simplify r is equals to 4r equals to 8, r equals to 2. Good. So then you can use the formula now. They tell you constant term is 7, which means you can just sub in r equal to 2 and then equate to 7. Exactly. Okay, let's do that. So let's just write down equate to 7 first in case I forget. So sub r equals to 2. So t2 plus 1, which is t3, is a 7, which is equals to 8 choose 2 times negative 1 power 2 times k power 2 times x to the power of, what do you think will be the power? 0 huh? Because they tell us it's constant. You can double check. Minus 4 times 2 plus 8 is 0. Because that's what we solved, right? Just walk backwards. Yeah, so anything power 0 is just a 1. You can remove it. So that is our answer. So this is sort of our answer already, our equation. We can solve for k. Negative 1 square is just 1. So now we have 8 choose 2. Use calculator. Sorry. 28k square equals to 7. So k square equals to 7 over 28, 1/4. Then k equals to plus minus half. Right, half times half is 1/4. Square root 1/4. But wait a minute, what did they tell us about the value of k? K is?
More than 0.
So here we have to
Recheck 1.
reject the negative, accept the positive only. That's our final answer. Okay, let me remove this. That's our final answer. Okay, good. Part 1 done. Move on. Part 2, using the value of k in part 1, show that there is no constant term in the expansion of whatever. Okay, this one is very simple. You just need to know that how do you get all the different power terms in this question. You just need to know that whenever you got something multiplied by another thing, you need to take the first term multiplied by the things inside, take the second guy multiplied by the things inside. Okay, then x power 4 means that whenever you multiply by any term inside, you get a certain power. And how do you represent any certain term, any generic term inside? And that requires you, what I'm really asking you to do here is, you need to find out what is the r+1 formula for this expansion here, the x minus k over x cubed power 8. And we have already found that, right? So it's just this expression, 8 choose r times -1 power r times k power r times x power -4r plus 8. Then we can just paste it here. Okay, this is the r+1 formula. Then whenever we want to show this kind of question, here's how you can do it. You can take the first term, you multiply by a tr+1. So we multiply. We'll just get back the same thing. And then you can do the second time, x power 4 times tr+1. We'll just get this same thing here, but you multiply the x power 4, which means that you can add the powers together. Okay, so this simplifies into +8 plus 4, and then you simplify a bit more, you get +12. Is that okay? And the emphasis should be on the power. So over here, if I can just erase this highlighter, the power here and the power here. What you can, oh sorry, not there, it's here. Maybe I should have left a line now. I should say that if you want a constant, if constant term exists, then the -4r plus 8 should be equals to 0. If you try to solve for r, what do you get? You get r equals to, you'll get r equals to 2. Let me see, this shouldn't be the case. I should be getting a wrong answer. Let me think a bit. -4r plus 8. Sorry, let me think a little bit. -3r8 minus r, I get did I do something wrongly? Let me double check. 2. Something is wrong. Let me just double check. You said we concluded r equals to 2, right? So that means the T3 will be 8 choose 2 times x power 8 minus 2 is 6 times, oh wait, I can just use the final formula. -1 power 2 times k power 2 times x to the power of 0, which is a constant. No constant term. There's something wrong with this question. Do you notice something? You can actually get a constant, right? So this guy, if you expand it, you will get if an r is equal to 2, you'll get a constant. Then you multiply by 1, you'll get a constant. Oh, so this question is wrong. Okay. I'm so sorry. Let me change this instead of constant to something else. Let's not talk about constant. Let's talk about linear. Linear means x power 1. Okay, sorry, I'm changing the question. I'll edit this and send it to you. Show that there's no linear term. Okay, so let's redo the question with a slight modification. So instead of constant, we'll talk about linear. Then here it should be if a linear term exists. What will we expect? We'll expect the power here to be equals to 1. Then if we try to solve for r, I think we will get 7 over 4, right? Yes? Which is not integer. Our r must always be an integer. Okay, must always be a whole number. If you remember, I think I talked about it briefly. If I can find the notes. Oh, that's not the right notes. Yes, over here, right? N and r, they must both be positive integers. Okay, they must both be positive integers. Must be whole numbers, no decimals. 7 over 4 will have decimals. So if we look back at the this guy. Yeah, if you look back over here, we get a 7 over 4, which is wrong. It shouldn't be 7 over 4. It cannot be a non-integer. Okay, that means that impossible. This is impossible. What we call a contradiction. Okay, we start off by assuming that if the linear term does exist, give them the benefit of the doubt. Let them assume it's true. Then this must also be true, equals to 1. But then we solve for r and we get something that is not an integer. It contradicts our expectation. Then we found a contradiction. So it means that the original assumption is wrong. Okay, same thing. We're going to do the same argument here. If for the x power 4 times tr plus 1, if it's linear term exists, that, TERM, then we get the negative, we should expect the negative 4r plus 12 to be equals to 1. Solving, we get 4r equals 12 minus 1, which is 11, and r equals 11 over 4. Again, this is not an integer, which means that we will have contradiction, which means that linear term does not exist. D and E does not exist. Okay? Okay, good. Okay, that is part 2 done. Sorry for the mistake with the question. It should be a linear. Constant can still exist. Okay. Let's go on to the next question. And the last question, finally, question 7. Okay, let's see. I'll start a new page. What is question 7? In the binomial, wrong spelling. Binomial expansion of 3 over x squared plus x holding power 8, explain why every term is dependent on x. Meaning that there is no constant. Okay, It's saying that there are no constants. Let's see. So very simple. You just use TR plus 1. Now TR plus 1 will be what? So first you must identify your A, your B, and your N. Can you tell me what's A?
3 over x squared
Simplify, it becomes 3 times x power.
-2
Okay, B will be,
x
N will be.
8
Okay, good. Then we can use the formula. N, so what would it be? Can you remember?
8 over r
Times.
times 3x to the power of -2 to the power of n. I mean 8 minus r. Then x to the power of r.
Good. Okay. Then we simplify. It choose r times 3 power 8 minus r times x power -2 times to the power of 8 minus r, which means you need to multiply them. I'll multiply it later. Times x power r. Copy down the exact same thing, but this time we simplify. So x power -2 times 8 minus r plus r. Simplify a bit more. We get minus 16 plus 2r plus r. This is really just 3r. Then we can start to answer the question. So how do you show that there is no constants? Constants means it's x power
0 minus
0.
16 plus 3r equals 0. Then
3r.
because you get not in positive integer, then yeah.
Yeah, then therefore it's a contradiction. Oh,
Yeah.
okay, good. Part 2. Find the term independent of x in the expansion of blah, blah, blah. Okay, so here what we can do is translate this English into math. Term independent of x is really just saying constant. Okay, so x power 0. So we need x power 0 after we multiply by 5, x power 0 after we multiply by -2x. So let's see what we can do. How if you want 5 multiplied by something give you constant, that means the inside must also be a constant, power 0. But is that possible?
Don't have.
Don't have. So
No
we can skip
constant.
the 5. Correct. So we can skip this 5. 5 times anything inside will not contribute to the constant. So that means we now focus on the -2x. What must you multiply by so you can get constant?
X to the power of -1.
-1, right? So that's what we're going to find first. So take the power, we equate to -1. Then we can solve for r. Try to solve for r. Bring the 16 over, positive 16 minus 1, 15. Have or not?
Yeah, have.
Positive integer. So that means that we actually got T6. That will be the one that has a x power -1. Sub in. No. So take note. Remember, this one r plus 1, here is r. Must always -1. Here is 6, -1 is actually 5. Okay, don't get confused. So 3 power 8 minus 5, simplify straight away is 3 times x power -1. Calculator. I need a calculator for this. 8, choose 5 times 3 power 3. 1512. X power -1. Okay, so that's the only guy that will contribute to your -1 power. So 3 over x squared plus x power 8 times 5 minus 2x will equals to ... plus 1512 x power -1 multiplied by -2x plus ... That all the other terms are not constants anymore. Okay, so we can simplify this. Multiply out 1512 times -2, you'll get a -3024. Plus ... Okay, then that is our answer. Can? Oh, by the way, do you know what is Wolfram alpha?
Say again.
Wolfram alpha. Have you heard of it?
No.
Okay, I'm gonna show you. I'm gonna give you more homework questions. Then you can check with Wolfram alpha. Let me show you. Wait a minute. Wolfram. Share screen here. Oh, it might take a while to load. Okay, so this is a website called wolframalpha.com. Basically, you can type in your equations. So if you remember the equation just now we had was what? 3 over x squared plus x, right? So what you can do is you can type in open bracket 3 over, this slash means divide, x power 2. Sometimes you need brackets because it's a robot. You have to really explain to it. Bracket here means it's at the denominator. So 3 over x squared, then you plus x, and then power means caret above the number 6, power 8. Then you put asterisk means multiply, close the bracket, 5 minus 2x. Okay, maybe you don't need the asterisk. I think it's smart enough to know this is multiplication. Then you just press this equal sign, compute. Wait a bit. And see, input, they automatically read as the whatever we are expanding. And they give you all the information. You need to wait a bit, it's quite slow. Then eventually, ta-da, you'll get the expanded form. Can see or not? They do for you. Then you can use this to help you to double check. What we wanted, we wanted the constant, right? Negative 3024. Right over here. Computer can do it way faster, but the purpose of the lesson is to do it manually. This one is to help you to check. Okay.
Okay.
Yeah, you can use Wolfram Alpha if you want. All right. I still got extra 8 minutes plus. I gave you a break. Okay, I'm just gonna go through more questions.
Okay.
Let me find more. Let me find the other worksheet. Your homework questions from the binomial theorem or worksheet. Okay, hold on a second. Okay, you have the worksheet with you?
Which one?
The binomial theorem questions all.
Yeah.
Have okay, can then I'll go through that. Sort by date. Hello data. Wait, I'll start a new worksheet. Okay. And what question did we last stop at? I can't remember. Let me check. Okay, let's go. So where did we stop at? Did I go through question 3 already? I can't remember. Let me find the notes. Do you remember?
Oh. No.
Okay, let me see. Notes. Is it this one? Did I send you this? Oh, I might have forgot to send you the notes. Oops. Okay. Let's see. This is question 3. Oh, I went through question 3. That's where I last stopped. Okay. Maybe I'll just continue on these. Hold on a second. No, I shouldn't continue. I'll start a new page. Start a new worksheet. Okay, so I last stopped at question 3, right? That means that I can continue on question 4 onwards. I hope you have the worksheet open. We'll be looking at the question 4 onwards. So in the expansion of the expression x plus 3 squared, this is of x plus 3 squared multiplied by x plus 1 power n, the coefficient of the quadratic term is 121. So your goal is to find the value of n. Did I assign that as homework or not? Was that homework? Yes, it was homework, right? Question 4 and question 5. Yes. I sent you the work solution already for question 5. I remember I made a extra video. You can go check it out. I hope I added to the correct playlist. Then question 4, I also wrote up the solution. Do you want me to go through that?
Sure.
Can I? Okay, I'll go through question 4 from that homework. If I can find the file first. This one explained already. Question 4. Okay, your working is. Actually, you got it right. Oh, yeah, you got it right. Okay, there's nothing to go through. You know how to solve this question. Basically, you just need to expand the individual factors. X plus 3 square expand. Then x plus 1 power n, you also expand it in this manual way. And then you have to multiply them together, but only find the relevant terms. In this case, they gave you coefficient of the quadratic. So you just focus on the quadratic terms. 1x squared, 6nx squared, and 9n times n minus 1 over 2x squared. So you can just get the coefficient by adding them all together, equate to 121. Then you try to solve for n. Yeah, you got it. Okay, you understand already. I can move on. Okay, we'll do more difficult questions. Okay. Question 6. Let's go. Let's start from question 6. Okay, good. So question 6. Find the coefficient of x power 11 in the expansion of this value, x squared plus 2 over x squared times 9, 2x plus 3 over 4x. Let me show you another way instead of using r plus 1 formula. This is the manual hardcore way if you really cannot remember formulas. Here's how you do it. Just manually expand. The first guy is power 9 plus, then you think about it. 2 times 9 is what?
2 times 9, 18.
18, okay. Then if you drop it by 1, so of course you must have a coefficient, 9 choose 0, 9 choose 1, drop it by 1. So now it becomes power 8. Then the other guy, 2 over x squared power 1. What happens to your overall power? You see, you minus 1 copy of your power 2, right? X squared you decrease by 1, so minus 1 copy of the 2. But you have to add on 1 copy of the 2 over x squared, which is really just 2 times x power negative 2, right? So 1 copy of negative 2. What's the overall net change? It's minus 4, correct?
Mm-hmm.
So that means your power dropped by minus 4. So start from 18, minus 4 becomes 14. Then if you want power 11, what do you think? How do you get power 11?
Term. Wait, no way.
Don't have. You minus 4 again, then you get 11. But that's when you have to realize that this is only for this part here. You still need to multiply by 2x plus 3 over 4 over x. 3 over 4x. So that means that actually here after you minus 4, you get 11. You can multiply 11 by x, right? Oh wait, sorry. 11 by 3 over 4x. Does that make sense? Actually not correct. Oh, sorry, my math failed. 14 minus 4 is 10. What, 11? Oh my goodness. Okay, 14 minus 4 is 10. Yes. Then hence you multiply by 2x, then you can get your power 11. Make sense? So you see, you don't need to use r plus 1 formula. Just whack only. Just expand everything. Sometimes it's faster. I think it's faster. Then you just get x squared power 7, 2 over x squared power 2 plus ... Don't care already. This is what we need. Multiply it by the 2x. We can get our power 11. So now I think it's better if we just simplify. I'm just gonna write it out. This guy, you multiply it by 2x. Then we will get our power 11 term. So we just simplify. So 9 choose 2. Using a calculator, I get 36. Multiply by x squared power 7, so power 14, times 2 squared over x. 2 times 2 is 4. 2 squared is nothing but 4. So 4 over x power 4 times 2x. So it's just 36 times 4 times 2 times x power 14 plus 1 minus 4, which is 11, as expected. Then we can get our 36 times 4 times 2, which is 288 x power 11. Any others? If I minus 4 again, what do I get? I'll get a 6. 6, can I multiply by anything here to give me power 11?
No.
Don't have. Then you don't need already. Do you think this is faster than R plus 1 formula?
Yeah.
A bit. But of course, it depends on whether you remember the binomial expansion pattern. 9 choose 0, 9 choose 1, 9 choose 2, 9, 8, 7, 0, 1, 2. I skip a step. I never break down the 0 because I already know ahead of time power 0 is always equal to 1. So I skip a step. I don't write down the power 0. Okay, so the answer is just 288. Easy. Okay. I think by now you already did so many questions, you should know how to expand very fast. Okay, next question. Go. Question 7. In the expansion of x squared minus k over 2x power 9, where k is a positive constant, so k more than 0. Term independent of x is 5376. So that means x power 0 is 5376. Then part 1, you want to show that k is equal to 4. How? Let's just do the trick again. This time we realize that maybe r plus 1 is faster. Why? Because let's take a look. If we manually go and expand this x squared minus k over 2x power 9, what will we get? We'll get 9 choose 0 times x squared power 9 times the other guy power 0. Oh, by the way, a is x squared, b is negative k over 2x, which can be simplified as negative k over 2 times x power negative 1. And the power n, is equals to 9. Then you can carry on expanding. 9 choose 1, x squared power 8 times negative k over 2 times x power negative 1 power 1. Let's check the pattern. 2 times 9, 18. Then we have to reduce minus 1 copy of a power 2 and add on 1 copy of the negative 1. Net change will be negative 2 minus 1, which is negative 3. So let me just shrink this down. Minus 3, we get 15. What do we eventually want? Constant,
X
right?
power 0.
Then you can imagine minus 3, just 5 more times. Wow, my hand very tired already. If you want to manually write it out, a bit tiring, right? So maybe r plus 1 formula is nicer. But let's just continue. Let's see if without using r plus 1 formula, can we still solve this question? I think you can see the pattern. So let's count. How many times do you need to minus 3 to get to 0?
Oh, like right away.
How many minus 3s do you need to get to 0?
You need 5.
5 of them, right? Then let's see. Each time we subtract 3 one time, the power increased by 1. So if we need to subtract 3 5 times, the power the sort of denominator here needs to increase by 1 also 5 times. So straight away, yes, what is the final term? It should be 9 choose 6. Correct. Yes. Then after that, you raise to the power of, okay, I'm just gonna save some space. We'll put a dot in the middle. 9 choose 6 times x squared power, what is it? 8 minus 6. Is it 3 or is it power 2? Oh, sorry, not 8. Should be 9. Then it's 3. You're correct. I'm wrong. Okay, you are correct. Then after that, you take the negative k over 2 times x power negative 1 raised to the power of 6. Let's just double check if the power is correct. So 2 times 9 minus 6 is 3 plus negative 1 times 6. Does that give me a 0? Yes, right. 2 times 3 is 6, then minus 6. Okay, so that means this is our constant already. Then we can try to simplify this fellow. This is without using r plus 1 formula. This is equal to what? 5376. So that means we can just solve for k. 9 choose 6, use a calculator. What do I get? 84. Times x power 2 times 3 is a 6. Times negative k over 2 raised to the power of 6. Times x power negative 1 raised to the power of 6. This 2 will cancel off. You're left with 84 times negative k over 2 power 6 is actually the same as negative 1 power 6 times k over 2 power 6. Negative 1 power even is just a 1. So k over 2 power 6 is k power 6 over 2 power 6, which is 64, multiplied by 84 on the left equals 5376. Then you solve for k power 6, you'll get 5376 multiplied by 64, but you divide by 84. Let's see. Okay, 4096. Good. K power 6. Then solve for k. This one, plus minus 6 root 4096. Alternatively, never mind. Just use calculator. I think it's faster. You get a 4. Plus minus. But of course, since we already know k is a positive, right? Remember, k is more than 0. So we reject. And then therefore k equals to 4 only. K equals minus 4 is rejected. Okay, k equals to 4. Can? Shown. Is that okay?
Yeah.
Okay, part 1 done. Let's move on to part 2. Finish up the question now. Part 2, with this value of k, find the coefficient of x power 6. Do you want to use r plus 1 formula or do you want manual?
R plus 1.
R plus 1. Okay, let's do that. So here we try, again, a is x squared, b is negative 4 over 2. Here we can simplify because now k is an actual number. 4 over 2 is 2, so negative 2 over x. Simplify, it's negative 2 times x power minus 1. And n equals to 9. So how r plus 1 formula will be n choose r, so 9 choose r times, can you tell me? Bracket, what's inside?
X squared.
Power. What?
Wait, what are you on 5 again?
R plus 1, tr plus 1.
Oh yeah.
9
9 minus r. B, which is minus 2x power negative 1 r to the power of r.
Exactly. Good. Okay, then now we try to find the coefficient. So 9 choose r times negative 2 power r times x power. Okay, it will. Let's see. What do we get? Times x power 2 times 9 minus r is 18 minus 2r. And then negative 1 times r, so negative r. Simplify a bit more. 9 choose r, negative 2 power r times x power 18 minus 3r. Good. Okay. What else? Oh, sorry, I didn't see what you were writing. Saying something?
No, nothing.
Okay, Ken. Your video is on. Yeah, in case you don't. Okay, so now what do we want? We want to find the coefficient of x power 6 in the expansion of whatever multiplied by 9x power 6 plus 1. So we are not done yet. We need to take this fellow, multiply by, what is it? 9x power 6 plus 1. So how? That means we need to take our x power 6 multiplied by a constant, 1 multiplied by our x power 6. Right? Does that make sense? So let's check if these two terms exist or not. So how do we check it? First, maybe I color code it as dark green and purple. For the dark green, we need x power 0. Let's check if it exists. So we take our power 18 minus 3r, we equate to 0. Solving, we get r equal to 6. So it does exist. It's a positive integer. So then we can find our t, r plus 1, which is 6 plus 1, 7, which is 9 choose r is 6, multiplied by negative 2 power 6 times x power 18 minus 3r, 18 minus 3 times 6, which is a 0. Type in a calculator. Can you tell me what is it?
Okay.
The green color.
9 choose 6
times, oh, the dot here means times, by the way.
9 choose 6 is 84.
Okay,
Then
times. Or you can actually key in the entire thing inside the calculator straight away. Oh. But you can do it step by step also. Negative 2 power 6 is
64.
Correct. X power 0 means 1. So answer is
5376.
5,376. Okay, that is only for the green part. We later need to multiply by 9x power 6. I'll do that later, but first we find out the purple one, x power 6 from the binomial expansion. So x power 6 here means you need your 18 minus 3r power. Where's my 18 minus 3r? It's here. Oh, in case you are confused, 18 minus 3r equals to power 6. Solving for r, what do you get? I think it's a 2, right? Sorry, no, 4. Yes?
Yeah.
Correct? Can 18 minus 3 times 4 is 6. So r equal to 4. Yes. Okay, good. We got r equal to 4. What do we do next? We sub in the formula. So t r plus 1, 4 plus 1, 5. Equals to 9 choose 4 multiplied by negative 2 power 4 times x power 18 minus 3 times 4. Of course, we are expecting, as expected by design, we wanted it to be a 6. So now we can sub in the formula, the calculator. 9 choose 4 times bracket negative 2 bracket 4. What do you get?
4032.
Let me double check. I don't think that's correct. 9 choose 4 times negative 2 to the power 4. I think I got 2016. Let me just show you. Let me find my camera first. Yeah, where's my camera?
Oh yeah, 2016.
Oh, yes, 2016.
Yeah.
Okay, can. Let me just change screen. Oops. Okay, yes, 2016. All right, Ken. So yes, 2016. Not done yet. Now we need to find the, what is it? We need to find the coefficient of x power 6 using that value of k equal to 4. Okay, so then you just expand. Yes, just take the yellow multiplied by green, blue multiplied by the purple. So coef of x power, I forgot already, x power 6. It will simply be 9 times the green one, which is 5376, plus the blue one, which is 1, multiplied by the purple one, which is 2016. Then just type in calculator. 50,400. Pen?
Okay.
Yeah, then that's it. Then let me see if I need to go through anything else. I think the rest of the questions you can do already. Okay, so your homework will be finish up the rest of the questions until question 23.
Oh my god.
Yes. Cannot.
Cannot.
Okay, that's can try.
My math not good.
That is not true.
They never let me take A math.
You are doing very well, honestly. Okay, I'll start recording.